Welcome everyone to episode 46 of our MTCNA tutorial on the Masquerade action. Last session, we posed a question concerning source NAT and its functionality when your source IP address changes. In this video, we'll tell you what Masquerade is and how it works according to data from ChatGPT, and also test how efficient this action can be. If you refer to the NAT specific page in MikroTik's documentation and scroll down a bit, you'll find the Masquerade section. Masquerade has been defined as a unique subversion of the source NAT action that is used in scenarios when your IP address changes randomly, which in short means when your public IP is dynamic. Masquerade as a source NAT action operates in the post-routing stage as the last stage where packets are exiting the routing flow on layer 3. For a complete understanding of source NAT, you can refer to our last two videos on our YouTube channel. Anyhow, without a source NAT on the class AP, if we ping 8888 from the trainee router, our ping will fail, just as we explained in previous tutorials. So let's resolve this issue with a source NAT rule. The chain is source NAT and the source address is 10.0.0/24, which is the network of the WLAN1 to class AP interface on the trainee router. The action of this rule is source NAT as well, which will translate addresses to 192.168.77.237. which is the address assigned to the Ether1 to Internet of the class AP that is facing the main Internet switch and the wider Internet domain. With this source NAT on the class AP, our ping from R2 to 8888 now works. Given the current super hype about artificial intelligence, we decided to consult with ChatGPT in this video. So first, to make sure we're on the same page, we'll copy the Masquerade section into ChatGPT to let it grasp our current understanding of Masquerade. Next, we ask ChatGPT about the conditions in which a router's IP address can change dynamically. According to our AI coworker, a router's IP address can change dynamically under various conditions, including addresses obtained from a DHCP server, PPPoE, mobile networks, dual WAN scenarios, dynamic DNS, failover settings, load balancing, VPNs, and other similar conditions. We then asked ChatGPT for information regarding MikroTik solutions for dynamically changing IP addresses, to which it responded primarily with Masquerade, along with other less frequent solutions such as NAT helpers or black hole routes. And finally, we requested the algorithm of Masquerade. According to ChatGPT, when a LAN device sends a packet toward the WAN, that packet will be checked against the firewall rules of the source NAT chain. If the packet matches the Masquerade rule, the router replaces the IP address of the packet with the IP address of the outgoing interface. Next, the router adds an entry to its connection tracking table with the original as well as the new IP address. When a reply packet comes in from the WAN, the router checks the connections table to see if that response belongs to an existing connection. If the response packet belongs to an existing connection, the router translates the destination address of the packets back to the original source IP address and forwards it to the local device. If not, the packet will be dropped. And in case the connection record of a masqueraded connection is removed from the connections table, the next packet will be treated as a new packet to undergo the same routine. So now that we know how Masquerade works, let's see it working in Winbox. Our source NAT is still in place, so as expected, the ping from R2 to 8888 works. But as soon as we remove that NAT on the class AP, the ping fails and gives timeout results. Now, to resolve this disconnect using the Masquerade action, all we need to do is to create a new NAT rule with the source NAT chain for the out interface of Ether1 to Internet, which carries the IP address of 192.168.77.237, and set the action to Masquerade. As soon as this new rule is created, ping packets resume their successful flow. And in case you don't see this happening, go to the connections table and remove all existing records so that the class AP registers a new connection for this ping. Okay, so that's how easy the Masquerade works. But now, let's put it to the test and see if it can actually maintain connections in the event of an IP address change. If you refer to the interface window and open up one of the active interfaces, you can see that each interface has its own MAC address. Right now, we have a successful ping to 8888. Changing an interface's MAC address will potentially force the interface to acquire a new dynamic IP address, so we referred back to ChatGPT to see how we can make that alteration. According to ChatGPT, we can open the terminal window on the class AP, move down the interface and the Ethernet menus, select the interface of choice, and set a new MAC address for that interface. As soon as we confirm this command, we get a few timeouts on our ping and a few messages concerning the unreachability of 10.0.0.254 on the class AP. But as quickly as your ping timed out, you will start receiving successful ping replies again. A few seconds later, the class AP is disconnected, and once it reboots, you can see that along with the new MAC address, it had acquired a new IP address from its DHCP server. You can verify the change of the MAC address from the interfaces window and the newly and dynamically assigned IP address from the IP menu and the DHCP client submenu. By the way, remember that you don't necessarily have to assign the Masquerade action to the out interface. For instance, you can determine the source address of this action as 10.0.0/24 so that it only translates IP addresses of this range. And in the end, we gave ChatGPT one last visit to ask about Masquerade's use in multi-WAN or multi-gateway situations, and learned that it can be useful under these conditions as well. Masquerade will help to dynamically choose the public IP address of the interface through which the packet will exit, so that it's not limited by the WAN or gateway it will use. We also inquired about the use of Masquerade in the case of a WAN failover, which is similar to switching from one WAN to another in a multi-WAN scenario, and just as ChatGPT answered, Masquerade can also be used to address WAN failover. However, we also learned to use AI with a little bit of caution, because when we asked this final question, ChatGPT initially stated that Masquerade is not such a useful tool for WAN failover, but after a few attempts, it decided to dig a little deeper for a better answer. So, while absolutely phenomenal, bear in mind that AI has a long road ahead and you'd be wise to consult with other reliable sources for your learning experience. Next session, we'll deal with destination NAT. So until then, we're all ears for your questions and look forward to your hitting that subscribe button.